Ram Ram students. So today I am discussing about MIT USA Integration B 2023 qualifying round exam. There are 23 questions. So here I am discussing one by one. So first question is that question number 1 is integration of x the power 1 upon log x dx. ठीक है. So how to approach this question? Since log e is equal to 1, so here 1 I can use this property. Okay, so this is x the power log e upon log x dx. Okay, in logarithm we know that log a upon log b is equal to log b base a. Okay, so this is equal to x the power log x base e dx. Okay, since a the power log a base x is equal to x, so this quantity is equal to e dx. Okay, then integration of this quantity is equal to ex plus c. So this integral is equal to ex plus c. Okay. Okay. Now question number 2 is that integration of e की power x upon 1 plus e की power x into log 1 plus e की power x dx. Okay, so how to approach this problem? First of all, when we saw the quantity and when we assume is equal to t, after that when I differentiate there are 1 plus e की power x. Okay, so if log 1 plus e की power x is equal to 2t, okay, so differentiate both side is equal to 1 plus e की power x into e की power x dx is equal to dt. So this quantity becomes dt. So dt upon t, this is equal to log t. Okay, so where t is equal to log of 1 plus e की power x plus c. So this integral is equal to log of 1 plus e की power x plus c. Okay, so now we move to question number 3. I is equal to integration of 1 plus x square plus x cube plus x की power 4 into 1 minus x plus x square minus x cube plus x की power 4 dx. Okay, so there are a series, finite series, whose common ratio is x. This is finite gp. Okay, this is finite gp geometric progression with common ratio is equal to x, and first term ft is equal to 1. Okay, this is also finite gp whose common ratio is equal to minus x, and first term is equal to 1. So using the sum of series of a finite gp is equal to Sn a 1 minus r the power n upon 1 minus r. R is common ratio and a n is number of terms and a is first term. Okay, so using this fact, I is equal to 1 minus x to the power 5, there are 5 terms, upon 1 minus x into 1 plus x to the power 5 upon 1 plus x, because common ratio is minus x dx. Okay, so there are a minus b, this is a minus b, or this is a plus b. So a minus b into a plus b is equal to a square minus b square. So this quantity is equal to 1 minus s to the power 10 upon, same here, 1 minus x square dx. Okay, again this is a sum of a finite GP whose common ratio is x square. Okay, so if the common ratio of x square, then this term is x square to the power 5 equal to x power 10. So there are 5 terms, so this is equal to 1 minus x square plus x to the power 4 minus x power 6 plus x to the power 8 dx. Okay, because there are fifth term. Okay, so integrating 1 by 1, so integration of 1 is x, and x square is x cube by 3, x to the power 5 by 5 minus x to the power 7 by 7 plus x to the power 9 by 9 plus c. So this integral is equal to this integral, this quantity. Okay, so question number 5. I is equal to integration of 0 to 5 xc5. Okay, so this is equal to 0 to 4 xc5. ncr is equal to n factorial upon n minus r factorial into r factorial. Okay, we know. So xc5 is equal to 0 to 4 x factorial upon x minus 5 factorial into 5 factorial dx. Okay, since negative quantity factorial is equal to infinite, okay, 1 upon negative quantity factorial is equal to 0. Okay, this implies that. So here x belongs to 0 to 4, so x minus 5 belongs to 4 minus 5 and minus 5. Okay, so x minus 5 belongs to minus 1 to minus 5. Okay, implies that this quantity is negative. Okay, so negative factorial is equal to infinite, so 1 upon infinite is equal to 0, so this quantity goes to 0, implies that 0 dx is equal to 0, so this integral becomes 0. So now we move to next question. Question number 6. I is equal to x plus sine x plus x cos x plus sine x into cos x dx. There are 4 terms. Okay, so if I factorize this quantity, then we saw a pattern. Okay, or a important fact. So if I common x plus sine x, there are cos x in both the terms, so I common cos x, so remaining part is x plus sin x. So there are x plus sin s, there are also x plus sin s, so I separate x plus sin x, and remaining part is 1 plus cos x dx. Okay, if this quantity I assume is equal to t, because their derivative is given here, so let x plus sin x is equal to t, so 1 plus cos x dx is equal to dt. Okay, so this quantity is equal to dt, so there there dt. Okay, so integration of t is t square by 2, here t is x plus sin x square upon t plus c. Okay, so this integral is equal to x plus sin x का whole square upon 2 plus c. Okay, now next question is question number 7. I is equal to sin square x plus cos square x plus tan square x plus cot square x plus sec square x plus cosec square x dx. Okay, so here some trigonometric calculation. So we know sin square x plus cos square is equal to 1, and 1 plus tan square x is equal to sec square x. Okay, and 1 plus cot square x is equal to cosec square x, so we add 1, so we subtract minus 1. Okay, so there are 2 sec x and 2 cosec square x. Okay, so this integral becomes 2 sec square x plus cosec square x minus 1 dx. Okay, so integration of sec x is equal to tan x to 2 tan x, and integration of cosec square x is equal to minus cot x, and integration of 1 is equal to minus x plus c. So this integral is equal to this quantity. Okay, okay, question number 7 is equal to question number 8. Okay, now question number 8 is I is equal to integration from 0 to 2 pi greatest integer of 2023 sin x dx. Okay, so we know how to plot the graph of greatest integer function. So first of all we need to know what is greatest integer function. So greatest integer function, okay, the graph of greatest integer function is like that. Okay, and this input is 1 2 3 4 5, okay, and so on, and this is minus 1 minus 2 minus 3, and this is 1 2 3. So greatest integer function is equal to when x lie between n to n plus 1, so greatest integer x is equal to n, where n belongs to set of integers. Okay, so this is greatest integer function. Okay, this is -1, -2, this is -3. Okay, this is greatest integer function. So here there are two ways to solve this integral. First is via pattern, and second is if we plot this integral using a fractional part function. Okay, since we know that every real number x is equal to written as sum of greatest integer function plus sum of fractional part function. Okay, this is fractional part function, this is fractional part function, and this is lie between 0 and 1. Okay, so the first method I apply. Okay, so what is first method? M1. Okay, so I is equal to 0 to 2 pi integration 2023 sine x dx. So if we solve like I1 integration from 0 to pi 0 to, here I take like ik, I assume 0 to 2 pi k sine x dx, where k belongs to integer. Okay, so I1 is sine x dx. Okay, so the graph of sine x like that. Okay, this is 2 pi, this is pi, this is 0. Okay, the height is 1, here -1. Okay, so if we plot the graph of greatest integer of sine x, since this quantity lie between 0 to 1, so the greatest integer of this quantity is 0. Okay, and pi by 2, the sign is goes to 1, so the greatest integer quantity is 1, and other point the greatest integer quantity goes to 0. Okay, and this, for this x, sin is lie between -1 to 0, so greatest integer is -1. Okay, this is -1. So the graph of this quantity is like that. So integral is equal to area under this curve. Okay, with algebraic sum. Okay, so from 0 to pi, the area between 0 to pi. Okay, x when 0 to pi, then area. Okay, and area when pi to 2 pi. Okay, when 0 to pi, then area is equal to 0. When x pi to 2 pi, then this area is equal to length is pi and height is 1, so pi into 1 is equal to pi, so this is pi. Because this is area below the x-axis, so this is quantity is minus pi. Okay, because we sum as algebraic sum. Okay, so this is equal to minus pi, so this quantity is equal to minus pi, so I1 is equal to minus pi. So now we calculate I2. So I2 is equal to integration from 0 to 2 pi to sine x greatest integer dx. So we need to draw the graph of 2 sine x. Okay, so this is 2 and this is -2 and this is 1 and this is -1. Okay, this is 0. and this height, this is 2 pi. Okay, so we need to draw horizontal and corresponding vertical lines to draw the graph of 2 sin x का greatest integer. Okay, so we need to draw horizontal lines and corresponding vertical lines. Okay, okay, so the greatest integer is taken the lower projection of the graph. Okay, so this is greatest integer 2 sin x. Okay, so this integration is equal to area between 0 to pi plus area between pi to pi. Okay, so if we calculate this integral, this area, and this integral, this area, so this is minus negative area, this is positive area. Okay, this is negative, so this area is equal to this point is equal to 2 sin x is equal to 1. Okay, so x is equal to 1 by 2, sin x is equal to 1 by 2, so x is equal to pi by 6. Okay, so this point is pi by 6 and this point is pi minus pi by 6, and this point is pi plus pi by 6, and this point is 2 pi minus pi by 6. Okay, so this length is pi minus pi by 6, pi minus pi by 6 minus pi by 6, so this is equal to pi minus 2 pi by 6. Okay, implies that pi minus 2 pi by 3, pi by 3 is equal to 2 pi by 3. So this length is 2 pi by 3 and height is 1, so this is equal to 2 pi by 3 into 1, so 2 pi by 3. So this integral is equal to 2 pi by 3. Okay, okay, so for this area, length is pi plus pi by 6 minus pi, length is pi by 6 and height is 1. Okay, and same this integral is 2 pi minus pi by 6, so length is pi by 6 and height is 1, so this is 1 into pi by 6. So the sum of these two integrals is minus pi by 6 because this is below the x-axis, so this integral is minus pi by 6 minus pi by 6. Okay, and for this integral, length is 2 pi minus pi by 6, this length is 2 pi minus pi by 6 minus pi plus pi by 6. Okay, pi plus pi by 6, this is equal to pi minus 2 pi by 6 is equal to pi minus pi by 3 is equal to 2 pi by 3. Okay, so this length is pi by 2 pi by 3 and height is 2. Okay, so this area is equal to 2 pi by 3 into 2. Okay, so this is minus times minus 2 pi by 3 minus 2 pi by 3. Okay, okay, here is positive sign, here is negative sign, so this quantity cancel out. Okay, so this is minus pi by 3 minus 2 pi by 3 is equal to minus pi. So this I2 is also equal to minus pi. Similarly, I3 is so equal to minus pi, and so on. If we calculate Ik, this is also equal to minus pi, we assume. So by induction, we also say that Ik plus 1 is equal to minus pi. Okay, implies that Ik is equal to minus phi for all k belongs to natural number. Okay, so I2023 implies that 0 to 2 pi 2023 sine x dx is equal to minus pi. Okay, so here you need to work out, okay, for induction, okay, principle of mathematical induction, PMI. Okay, so you need to work. Now we come to second method, how to approach via fractional part function. Okay, so via method 2, I is equal to 0 to 2 pi greatest integer 2023 sine x dx. Okay, we know x is equal to sum of greatest integer plus fractional part function. Okay, the graph of fractional part function is like that. This is 0 1 2 3 minus 1 minus 2 and so on. Okay, this is x, this is x minus 1, this is x minus 2. Okay, if this point is n and this is n plus 1. Okay, so this line is x minus n. Okay, so here fractional part function is lie between 0 to 1. Okay, for all x belongs to real number. Okay, so if we replace x by sine 2023 sine x, okay, so here I replace x by 2023 sine x. So the greatest integer of 2023 sine x rational part also lie between 0 to 1. Okay, so if we plot the graph of 2023 sine x fractional part x, okay, the fractional part of 2023 sine x, so is equal to, since sine x 2023, this is 2023, this is minus 2023. Okay, this is 2023 sine x. But if we want to draw the fractional part of 2023 sine x, so the graph of fractional part of 2023 sine x lie between 0 to 1. Okay, so the graph of this quantity is equal to like that. So this is 1, if 1, so this is sine x, but this is, there are open circle, and this is sine x, but this is lie between 0 to 1. So like that. Okay, so this is 2023 sine x fractional part of. Okay, so this blue color graph represent 2023 sin x greatest integer, greatest fractional part. Okay, okay, so this graph behaves like sin x, and this graph behaves like if we add 1 on this graph, like if we add, this is if we if I add sin x plus 1, then this quantity, this x-axis becomes lower x-axis. Okay, so this quantity is sin x plus 1, so this is sin x plus 1. Okay, so between 0 to pi, this quantity is equal to sin x, and from pi to 2 pi, this quantity is equal to sin x plus 1. Okay, so for okay, so 2023 sin x is equivalent to, if x lie between 0 to pi, okay, but x not equal to pi by 2 is equal to sin x. Okay, so integration, if we integrate this sin x, so at one point area is equal to 0. Okay, okay, if x lie between pi to 2 pi, this quantity is equal to sin x plus 1, equivalent to sin x plus 1. So if we integrate I is equal to 0 to 2 pi, greatest integer of 2023 sin x dx is equal to 0 to pi by 2 sin x dx plus pi by 2 to pi sin x dx plus pi to 2 pi sin x plus 1 dx. Okay, so okay, now we come to next page. So this integral is equal to 0 to pi by 2 sin x dx plus pi by 2 to pi sin x dx plus pi to 2 pi 1 plus sin x dx. Okay, so this integral is minus cos x from 0 to pi by 2, and this is also minus cos x from pi by 2 to pi, and this is x minus cos x from pi to 2 pi. So this is minus cos pi by 2, cos pi by 2 is equal to 0, and minus cos 0 is equal to 1, so this quantity is 1. Okay, plus, and this quantity is minus cos pi is equal to minus 1, so this is 1. Okay, and this quantity is 2 pi minus cos 2 pi is equal to 1, and minus pi plus 1. Okay, so this is 2 plus 2 pi minus 1 minus pi minus 1, so this is cancel out, and 2 pi minus pi is equal to pi. Okay, so since I calculate fractional part, okay, this is I calculate here I fractional part of 2023 sin x. So here is a mistake. Here I taken fractional part of x. Okay, so here I calculate fractional part of x. Okay, so this integral, let us suppose this is I dash. Okay, so I dash is equal to pi. Okay, I dash equal to pi, well, means fractional part of 2023 sin x. Okay, so this is basically I dash. Okay, so this is equal to pi, but my original integral is equal to, since fractional part of x is equal to x minus greatest integer x. Okay, so greatest integer x is equal to x minus fractional part of x. Okay, so I use this identity to evaluate our original integral. So my original integral is equal to greatest integer of x is equal to x minus fractional part of x. So 2023, okay, sin x greatest integer is equal to 2023 sin x minus 2023 sin x. Okay, and apply integral from 0 to 2 pi dx, 0 to 2 pi dx, 0 to 2 pi dx. Okay, since 2023 0 to 2 pi sin x dx, and this integral is I dash, so we know that sin x a from 0 to 2 pi. Okay, the algebraic sum of this area is cancel out. This is plus alpha, this is minus alpha, so if we add alpha plus minus alpha is equal to 0. So the area, this is positive, this is minus positive, and equal in magnitude, so cancel out, so this is 0. Okay, so 0 minus I dash, and I dash is equal to pi. Here I calculated I dash is equal to pi. Okay, so my original integral is 0 minus pi is equal to minus pi, so this integral is equal to minus pi. Okay, from our first method I calculate this is also minus pi. Okay, so this type of integral either we solve via pattern or this identity, using this identity. Okay, so now I come to next question. Okay, so question number 9. Question number 9. What is my 9 question? I is integral of 2 log x plus 1 e the power log x whole square dx. Okay, so here is one important integral, like this type integral. If we integrate differentiate dy dx e the power f into g is equal to, first using first into second, so this is equal to e the power f into z dash plus z into e the power f into f dash. Okay, so if we integrate both side, d over dx e the power f into g dx is equal to integration e if we common e की power f, then g dash plus g into f dash dx. Okay, so this is equal to e to power f into g. Okay, so this integral e to power f g dash plus g into f dash dx is equal to this. Okay, so I using this identity. Okay, this is happen for all f and g which is continuous their domain. So here need to, here this is like f. Okay, this is f, we need to find out z. So if we compare this integral and this integral, so we come to g. Okay, so we come to next page. Okay, so integration e to power f g dash plus g into f dash dx is equal to e to power f into g. Okay, and my question is that integration to the power 2 into log x plus 1 e to power log x whole square dx. Okay, here from the observation this is f, this is f, so f is equal to log x to the power 2. Okay, so since this quantity is equal to this quantity, so z dash plus z into f dash is equal to 2 log x 1 plus 2 log x. Okay, so z dash plus z f dash is 2 log x into log x, integration of log x is 1 upon x. Okay, equal to 1 plus 2 log x. Okay, so this is 2g, g dash plus 2g upon x log x is equal to 1 plus 2 log x. So from here and here we saw that this quantity is equal to 2, so 2z upon x is equal to 2. Okay, so 2 cancel out, so g is equal to x. This is also verified that g dash is equal to 1, so g dash is equal to 1. Okay, so g is equal to x. So my option is my answer is that g into e to the power x, so g is x, e to the power f, f is log x to the power 2. Okay, so this integration is this quantity. Okay, okay, so we move on question number 10. Okay, so question number 10 is I is equal to integration of 1 minus s to the power 3 plus x minus x square की power 3 plus x square minus 1 power 3 minus 3 1 minus x 1 x minus x square minus 1 dx. Okay, so this is our integrand. So this is like a cube plus b cube plus c cube minus 3abc. So we know that a cube plus b cube plus c cube minus 3abc equal to 0 if a plus b plus c is equal to 0. Okay, so we need to verify, if we say a, this is b, this is c, we need to verify that a plus b plus c is equal to 0. Okay, so a is 1 minus x, b is x minus x square, and c is x square minus 1. Okay, so this cancel out and this quantity is cancel out, so this is equal to 0. So this quantity is equal to 0, so this integrand becomes 0. Okay, so 0 dx is equal to 0, so this integral is equal to 0. Okay, so now move on question number 11. Okay, question number 11. So our integral is from minus 2023 to 2023, such that integral of mod x minus 1 minus mod minus 1 mod minus dot dot minus 1 mod, okay, dot dot dx. There are 2023 minus ones, okay. So how this integral we calculated? There are two methods via pattern, okay. So first I approach via pattern, okay. Let us suppose like that, like I1, if this is equal to minus 1 to 1 mod x minus 1 the mod dx, like if we assume ik like that, this is minus k to k, and minus mod x minus 1 the mod minus 1 the mod dot dot minus 1 the mod, okay. This is, there are k minus ones, okay. So first of all I calculate I1, okay. So we need to draw this graph. So integral is area between this graph and x-axis, okay. So basically area under curve, so this is mod x, okay. This is our mod x, okay. This is mod x. We need to draw mod x minus 1, so this quantity is mod x minus 1, okay. So we need to mod of complete quantity, so this quantity is like that, okay. So this is minus 1, this is plus 1, okay. So our original function like that, okay. This is minus 1, this is plus 1, this is 0. So we need to find out the graph between found out the area between minus 1 to 1. So this is area, so the length is 2 and height is 1, so area is half 2 into 1, so this is 1, okay. 1 square unit, this is above the x-axis, so this integral is equal to 1. So if base is 2 and height is 1, then area is equal to 1, okay. If this type of integral, this type of triangle happen, then we directly say the area of this triangle is 1, okay. So if a b c and height is like 1 and base is 2, so this area is half 2 into 1 is equal to 1, okay. So 1 square unit, okay. So I calculated I2, so I2 is equal to from minus 2 to 2 mod x minus 1 the mod minus 1 the mod, okay, dx. So I calculated mod x minus 1 the mod. What is the graph? The graph is like that, okay. So this is mod x minus 1 the mod, okay. We need to subtract minus 1, so my x axis become this line, okay. Because I subtract minus 1, then we need to take full mod, then below the x-axis portion goes to above the x-axis portion. Okay, so this is behaves like that. Okay, so our original graph becomes like that. This is -2, this is -1, 0, 1, 2. So this is our original function. Okay, this is mod x minus 1, the complete mod, -1, the complete mod. Okay, so there are two triangles, whose each area is equal to 1. This area is 1, this area is 1, so complete area is 2. Okay, so this is 1 plus 1 is equal to 2, because there are two triangles. Okay, there are two triangles. Okay, each area is 1. Okay, so this integral is equal to 2, because this function gives two triangle. Okay, so if I calculated I3 from -3 to 3, this is mod x minus 1 minus 1 minus 1. Okay, there are 3 minus 1. Okay, so if I draw this graph, there are three triangles. Okay, here there is a pattern. If there is a two triangle, then this is symmetric triangle. Okay, if there is a one triangle, this is on the y-axis. Okay, so there are 3 minus 1s. Okay, there are 3 minus 1s, so there are one triangle on y-axis and other two triangles are symmetric. Okay, so this point is -1, this is -1, this is 1, this is 3. Okay, so there are three triangles, each area is equal to 1. Okay, so the sum of area of some three triangles is equal to 3, so this is integral equal to 3. Okay, similarly, if we draw ik, okay, like ik is like that, -k to k belongs to natural number. Okay, mod x minus 1, the mod -1, complete mod, dot -1. Okay, complete mod. Okay, this is k minus 1's. Okay, dx. So there are two cases. Okay, if k is odd, if k is even. Okay, if k is odd, there are one triangle on the y-axis and other triangles like that. Okay, and so on. If k is even, then triangle like that. Okay, so there are total k triangles. Okay, in each cases. So integral in both the cases is equal to area between triangles. So there are k triangles, here also k triangles, and each triangles have area is equal to 1. Okay, so this quantity is equal to k. There are k triangles. Okay, because sum of k area of k triangles is equal to k. So this integrals is equal to k. Okay, either k is even or odd, so ik is equal to k square unit. Okay, but this integral, so no meaning of square unit. Okay, so if we calculate our original integral, what is our original integral? Our original integral is I 2023, this is minus 2023 plus 2023 mod x minus 1 mod minus 1 mod dot dot minus 1 mod. Okay, this is dot dot. Okay, dx. Okay, if we like that. Okay, there are 2023 minus 1s. Okay, so the graph is, we say directly this is equal to 2023, but if we draw this graph like that, so we come to the point, my graph is like that. Okay, this height is 1. Okay, so this is minus 1, this is 1. Okay, this is 3, this is 5, this is 2021 and 2023, this is minus 3, this is minus 2021 minus 2023. Okay, so there are 2023 triangles. Okay, and area of each triangle is, base is 2 and height is 1, so 1 by 2, 2 into 1 is equal to 1. So each area is 1 and there are 2023 triangles, so sum of 1 up to 2023 is equal to 2023. Okay, so this area, this is integral of this function. Okay, so we come to next question, question number 12. Okay, question number 12. I is equal to integration of sine the power 6x plus cos the power 6x plus 3 sine square x cos square x dx. Okay, as we know that sine the power 6x cos the power 6x plus 3 sine square x plus cos into cos square x, since this quantity is equal to sine square the power 3 cos square the power 3 plus 3 sine square x into cos square x. So we use this formula like that, a cube plus b cube is equal to a plus b into a square plus b square minus ab. So this quantity becomes like that, sine square x plus cos square x into sine the power 4x plus cos the power 4x minus sine square x into cos square x. Okay, plus 3 sine square x into cos square x. Okay, so this quantity is 1. Okay, so remaining part is sine square sine the power 4x plus cos the power 4x minus sine square x into cos square x plus 3 sine square x into cos square x. So this quantity is equal to 2 sin square x into cos square x. So this is sin the power 4x plus cos the power 4x plus 2 sin square x into cos square x. So this quantity is equal to sin square x plus cos square x the power 2. So this is 1. So 1 the power 2 is equal to 1. So this quantity is equal to 1. So basically this integral becomes I is equal to integration of 1. Okay, this is x. Okay, so plus c. So this integral is equal to x plus c. Okay, now come to next question, question number 13. Okay, I is equal to x plus e plus 1 into s the power e into e the power x dx. Okay, so if we multiply this quantity to this quantity, okay, so we come to s into e plus 1 into s the power e and e to power s dx. Okay, and if we differentiate e to the power x into f d by dx is equal to, we come to use first into second. So this is a to power x into f dash plus f into e to power x. Okay, and if we common e to the power x, then this is f dash plus f. Okay, so if we integrate both side, so this is d over dx e to the power x into f dx is equal to integrate e to the power x f plus f dash dx. Okay, so this is equal to, basically this is e to the power x into f, so this is e to the power f into f. Okay, so this integral I use to integrate this quantity. Okay, so this is e to the power x. Okay, and we need to find out what is f. Okay, so if I say, okay, this is basically s the power. Okay, this is basically, if we multiply s the power here s the power, if we multiply this quantity, this and this, then this is x into s the power e, and basically this is equal to s the power e plus 1. Okay, okay, if we say this is my f, then we need to show this is f dash. Okay, so if we take f is equal to s the power e plus 1, so f dash is equal to e plus 1 into s the power e, so this is f dash. So my answer is that e to the power s into f, so f is e to the power x s to the power e plus 1. Okay, plus c. So this is our solution. Okay, so answer is e to the power x into s to the power e plus 1 plus c. Okay, so move to next question, question number 14. Okay, question number 14. What is our 14 question number? Integration from 0 to 1, there are two part, s square upon 2 minus s square plus 2x upon 1 plus x dx. Okay, so if we calculate one by one like that, so let us assume I first calculated I1 is equal to from 0 to 1 x square 2 minus x square dx. Okay, and this is equal to 0 to 1. If we subtract minus 2 and add 2, this is equal to this quantity. And if we separate into part, okay, so this is equal to 0 to 1 minus 2 upon x square minus 2, okay, dx. Okay, so this integral is minus x and minus 2 upon 2 under root 2 log x minus root 2 upon x plus root 2 mod, okay, from 0 to 1. How I calculated this integral? Because we know that integration of x square minus a square dx is equal to 1 upon 2a log x minus a x plus a, the complete mod. Okay, I using this formula for calculating this integral. Okay, so if I put upper limit on this integral, this is equal to minus 1 and this is cancel out, minus 1 upon root 2 log 1 minus root 2 upon 1 plus root 2. And if we put lower limit on this integrand, this is basically 0, this is 0 0 root 2 upon root 2 minus, and there are mod, so this is log 1 is equal to 0, so this is quantity equal to this quantity. Okay, so we know log a upon b is equal to log minus times b upon a. Okay, so I use this formula. Okay, so this is minus 1 plus 1 upon root 2 log 1 plus root 2 upon 1 minus root 2. Okay, and if I multiply via this 1 plus root 2 by 1 plus root 2 on upper and lower quantity like numerator and denominator, we come to the point minus 1 plus 1 upon root 2 log 1 plus root 2 the power 2, and this is 2 minus 1 the mod 1 minus 2 the mod is equal to 1 minus 2 the complete mod is equal to 1. Okay, so this is 1, so this quantity is equal to minus 1 plus 2 upon root 2 log 1 plus root 2, so this is equal to minus 1 plus root 2 log 1 plus root 2. Okay, so basically I1 is equal to this quantity. Okay, this is our I1. Okay, we need to calculate I2. Okay, so I2 is equal to integration from 0 to 1 2 x upon 1 plus x the complete under root dx. Okay, so there is a 1 plus x. If we put x is equal to tan square theta, then this under root cancel out. Okay, so the differentiation dx is equal to 2 tan theta, differentiation of tan theta is equal to sec square theta d theta. Okay, so this is integral 2 tan theta and 1 plus tan square theta the complete root into 2 tan theta into sec square theta d theta, and our limit is when x is equal to 0, okay, then theta is equal to 0, then x is equal to 1, then theta is equal to pi by 4. Okay, so this is 0 to pi by 4. Okay, so 0 to pi by 4, this is tan square. Okay, so root 2 tan theta, basically modulus of tan theta, but in between 0 to pi by 4 tan theta is positive, so modulus, no meaning of modulus. Okay, because modulus of tan theta is equal to tan theta if theta lie between 0 to pi by 4, because tan theta is positive between 0 to pi by 2. Okay, so this is tan theta, this is sec square theta, this is sec square theta, basically this is sec square theta, and under root sec square theta is equal to sec theta ka modulus, and between 0 to pi by 4 no meaning of modulus. Okay, this is sec theta, and this is 2 tan theta into sec square theta d theta, so this is cancel out. Okay, so this is equal to root 2 0 to pi by 4 tan square theta sec theta d theta. Okay, so we use this formula here to calculate in this integral. Tan square theta is equal to sec square theta minus 1, so this is 2 root 2 0 to pi by 4 sec square theta minus 1 into sec theta d theta. Okay, this is I2, so I2 is equal to 2 root 2 0 to pi by 4 sec square theta minus 1 into sec theta d theta. Okay, this is 2 root 2 0 to pi by 4 sec cube theta minus sec theta d theta. Okay, there again two integrals. Let us suppose we solve this via induction. Okay, we solve it via induction, because we know that if we solve this integral like sec x sec e power nx, okay, dx, so this is I solve via n minus 2 x into sec square x dx. Okay, okay, so via by part I use by part integration and solve this integration. Okay, so if we calculate this integral via this technique, okay, so I use this 2 root 2 0 to pi by 4. Okay, so basically I calculate first of all indefinite integral. We have like a indefinite integration. Okay, so 0 sec cube theta minus sec theta. Okay, like that. So I calculated like that, sec theta into sec square theta d theta minus sec theta. Okay, d theta, so this is sec theta integration of sec square theta d theta minus integration of differentiation of d theta sec theta and integration of sec square theta d theta complete d theta. Okay, minus integration of sec theta d theta. Okay, okay, so okay, so this integral is tan x, so this is sec theta into tan theta okay, okay, and for this integral this is like sec theta into tan theta. Okay, this is sec theta into tan theta, and this is tan theta d theta minus sec theta d theta. Okay, this is sec theta into tan square theta. Okay, this is sec theta. This integral is integration sec theta into tan square theta d theta. Okay, so after this calculation I come to this induction step. Okay, when I calculated this integral, I come to that point is sec the power n minus 2 x tan x upon 2 plus n minus 2 upon n minus 1 I n minus 2. If I say this is in. Okay, so basically here I use directly this formula. This is very calculative, so I use directly this inductive formula. Okay, okay. So this integral 2 root 2, this is sec t power sec x into tan x upon 2 minus n minus 2 1 upon 2 sec x integration of sec x. Okay, okay, integration of sec x or integration of sec x, this is I minus 2 implies that integration of sec x, this is integration of sec x is integration of sec x is equal to log sec x plus tan x. Okay, so this is log sec x plus tan x, and this integral sec x also equal to, this is plus 1, this is plus sign, log sec x sec theta. Basically यहाँ पे theta I use theta, sec theta plus tan theta. Okay, so this complete integration is this integration. Okay, lower limit is 0 and upper limit is pi by 4. Okay, so this is 2 root 2. When I put upper limit, sec pi by 4 is equal to root 2 and tan pi by 4 is 1 upon root upon 2, and this is basically plus half, this is minus 1, and this is cancel out, this is minus half. Okay, so sec pi by 4 is root 2 and tan pi by 4 is equal to 1, so this is basically minus half log root 2 plus 1. Okay, if we put lower limit, this is tan 0 0, this is tan 0 0 sec 1, so log 1 is equal to 0, this integral is equal to this integral, this quantity. Okay, so this is, if we multiply this quantity to inner portion, we come to like that, cancel out 2 2 cancel. Okay, this is cancel out, so this is root 2 into 2 is equal to 2 minus root 2 log root 2 plus 1. Okay, so this is basically I2. Okay, this quantity is basically I2. So we add I1 plus I2 for original integration. My I1 is equal to basically minus 1 plus root 2 log 1 plus root 2. Okay, so and I2 is this quantity. So I is equal to I1 plus I2 implies that minus 1 plus root 2 log 1 plus root 2, okay, and I2 is 2 minus root 2 log 1 plus root 2, okay. So this quantity and this quantity is cancelled out. This is equal to 2 minus 1 is equal to 1, okay. So I is equal to 1. I is, what is I? 0 to pi by 0 to 1, okay, x square upon 2 minus x square, okay, plus under root 2x upon 1 plus x dx is equal to 1. Basically this integral is equal to 1, okay. This is our 14 question, okay. So we come to question number 15. Question number 15, I is equal to integration 1 plus 2 into s the power 2022 upon s plus s the power 2023 dx, okay. So we know that integration of f dash upon f dx is equal to log f. How? If we put this quantities t like that, f is equal to t, then f dash dx is equal to dt. So this integral becomes 1 upon t dt is equal to log t, and t is equal to f, so log f. This is mod, okay. So I use this technique on calculating this integration. So if you multiply 2 s the power 2021, then we saw this and this quantity like this quantity, okay. So if I multiply like that, s the power 2021 s the power 2021 on numerator and denominator, 1 plus 2 is the power 2022 and s plus s the power 2023 dx, okay. So we come to the point s the power 2021 plus 2 is the power 4043, okay, upon is the power 2022 plus is the power 4044 dx, okay. So if we multiply this quantity to above quantity and this quantity to below quantity, we come to this integrand. So we need to find out our f from this quantity. If we say this quantity is our f, so this is our f dash, okay. So we need to verify this is our f dash. So if we take f is equal to s to power 2022 plus s to power 4044, then f dash is equal to 2022 s to power 2021 plus 4044 s to power 404143, okay. This is 43. So we cancel out 2022 from both sides, 2022, okay. So I taken 2022, this is basically s to the power 2021 plus 2 s to the power 4043, okay. So this is our f dash, but there is a sum. This part is not here, so I multiply this quantity and divide this quantity. So if we multiply 2022 and divide 2022, so we get our f dash. Okay, this is our f dash. Okay, so this is our f dash. So okay, so this is our f dash and this is f. So 1 upon 2022 s the power 2022 plus s the power 4044, and this is our f dash. Okay, this is f and this is f dash. So this integral is equal to 1 upon 2022 log f. F is s the power 2022 plus s the power 4044. Okay, so this is our I. Okay, so we come to our next question. Okay, so what is our next question? Question number 16. Okay, this is question number 15, and now we come to question number 17, because there is a question number 17. I is equal to 0 to 1 pi k goes to 0 to infinity 1 upon 1 plus s to the power 2 की power k dx. Okay, so if I calculated this quantity like that, k goes to 0 to n, limit n tend to infinity. Okay, like 1 plus x to the power 2 to the power k. Okay, so limit n goes to infinity, this quantity is equal to if we put k is equal to 0, then this is 1 plus x. If we put k is equal to 1 plus x square, 1 plus x to the power 4, 1 plus x to the power 8. Okay, dot 1 plus x to the power 2 to the power n. Okay, so if I multiplied this quantity by a 1 minus x into 1 minus x. Okay, so this is a minus b, this is a plus b. Okay, this is equal to a square minus b square. Okay, so limit n goes to infinity, and this is 1 minus x upon 1 minus x square, and this is 1 plus x square, 1 plus x to the power 4 dot 1 minus h 1 plus h to the power 2 to the power n. Okay, and this is again a plus b, a minus b. Okay, this is limit n goes to infinity, 1 minus x upon 1 minus s to the power 4 1 plus h to the power 4 or 1 plus h to the power 2 to the power n. Okay, so come to next page. Limit n goes to infinity, pi k goes to 0 to n, 1 upon 1 plus h to the power 2 की power k. This is limit n goes to infinity, 1 minus x upon 1 minus x की power 4, 1 plus h to the power 4 dot 1 plus h to the power 2 की power n. Okay, this is basically using this process a minus b a plus b, we come to that point 1 minus h to the power 2 to the power n plus 1. Okay, so we need to calculate I like that. 0 to 1 pi k goes to 0 to infinity, 1 upon 1 plus h to the power 2 to the power k dx. Okay, here x lie between 0 to 1, x lie between 0 to 1, so h to the power 2 to the power n plus 1 also lie between 0 to 1. When n goes to infinity, so this quantity h to the power 2 to the power n plus 1 goes to 0. Okay, so this quantity goes to 0, so this is basically this quantity is equal to 1 minus x upon 1. So basically 1 minus x. Okay, so basically we need to calculate integration of this integral. Okay, so I is equal to 0 to 1 pi k is equal to 0 to infinity 1 upon 1 plus h to the power 2 to the power k dx. Basically this quantity is equal to 1 minus x. Okay, so 0 to 1 minus x dx is equal to x minus x square upon 2 from 0 to 1 is equal to 1 minus 1 by 2 is equal to 1 by 2. Okay, so this integral is equal to basically 1 by 2. Okay, so we come to question number 18. So question number 18 is I is equal to sin x upon 2e to the power x plus cos x plus sin x dx. Okay, so if we take common e to the power minus x r multiplied e to the power minus x in numerator and denominator, so e to the power minus x sin x upon e to the power minus x 2 e to the power x plus cos x plus sin x. Okay, dx. So this integral e to the power minus x sin x upon 2 e to the power minus x sin x plus cos x dx. Okay, we know that from last problem integration of f dash upon f dx is equal to log f. Okay, I using this remark. Okay, so if we say this is our f, then this is verified, this is f dash. Okay, so let's verify. If we take f is equal to 2 plus e to the power minus x sin x plus cos x. Okay, so f dash is equal to e to the power minus x sin x plus cos x. Okay, minus times plus e to the power minus x, derivative of sin x is cos x, or derivative of cos x is minus sin x. Okay, this is basically if I take integration a common e to the power minus x, this is equal to minus sin x minus cos x. Okay, and cos x minus sin x. Okay, so this quantity cancel out. This is minus sin x into e to power minus x. Okay, so we need to multiply minus sign for making f dash. Okay, so now this is f dash. Okay, so this is equal to minus okay, basically this is basically minus 2 sin x. Okay, so we need to multiply minus 2. Okay, okay, so this is log, this is f 2 plus e to power minus x cos x plus sin x. Okay, so plus c, this is our integral. We also further simplify. Okay, so minus 1 by 2, this is equal to minus 1 by 2 log 2 plus e to power minus x sin x plus cos x dx. Okay, so this is also equal to log 2 plus 1 upon e power x sin x plus cos x. Okay, this is minus 1 by 2 log 2 e to power x plus sin x plus cos x minus log e to power x. Okay, this is equal to x. Okay, so if I multiplied minus sign, this is 1 by 2 x, this is equal to basically x minus log 2 e power x plus sin x plus cos x. Okay, plus c, so this integral is equal to this quantity. Okay, so we come to question number 19. Question number 19, I is equal to integration of log s by pi upon log x the power log pi e dx. Okay, okay, so I use this formula, log a by b is equal to log a minus log b. Okay, so this is equal to basically log x minus log pi upon log s the power log pi e dx. Okay, and this is equal to log x upon log x the power log pi e minus log pi the power log x the power log pi e. Okay, okay, so and this is equal to integration 1 upon log s the power pi e minus 1 minus log pi upon log s the power log pi e. Okay, dx. Okay, if we assume log x is equal to t, so this implies that 1 upon x dx is equal to dt. Okay, implies that dx is equal to x dt. Okay, from here x is equal to e to the power t. Okay, so basically e to the power t dt. Okay, Okay, so this quantity is equal to integration 1 upon t की power log pi, basically log pi, यहाँ this is log pi minus 1 minus log pi upon t to the power log pi e into e to the power t dt. Okay, so again I used previous identity. What is our previous identity? Integration of e power x f plus f dash dx is equal to e power x f plus c. Okay, I use this identity for finding this integral. Okay, so what is our I? This is 1 upon t to the power log pi e minus 1 plus, okay, plus or minus. Okay, I want to need to see minus. Okay, minus, this is minus log pi upon t to the power log pi e e to the power t dt. Okay, if we assume this is our f, okay, so we need to verify this is f dash. Okay, so f is equal to 1 upon t to the power log pi e minus 1. Okay, so f dash is equal to minus log minus times log pi e minus 1 upon t to the power log pi e. Okay, this is basically log pi plus log e. Log e is equal to 1, so this is minus log pi upon t to the power log pi e. This is also equal to f dash, so this is our f dash. Okay, so answer is that e to the power t f. Okay, what is our f? F is this quantity t to the power log pi e minus 1. Okay, and again I use this formula log pi e minus 1 is equal to log pi plus log e minus 1. This is 1, so cancel out log pi. Okay, this is log pi. This is equal to e to the power t 1 upon t to the power log pi. Okay, what is our t? T is our log x. Okay, so basically this is x and 1 upon log x to the power log pi plus c. This is our integral. Okay, now we come to question number 20. Okay, question number 20. What is our question number 20? I is equal to minus 3 by 2 to minus half is the power 5 plus 5 is the power 4 plus 10 is the power 3, 8 is the power 2 plus x dx. Okay, so there are very typical limits, so we need to observe some thing on the integral. Okay, so we observe via Pascal triangle. What is our Pascal triangle? 1 1 1 2 1 1 3 3 1 1 4 6 4 1 1 5 10 10 5 1. Okay, so this is our 1 plus x the power 5. Okay, so what is our x to the power 5? This is basically s to the power 5 plus 5 s to the power 4 plus 10 s to the power 3 plus 10 s to the power 2 plus 5 x plus 1. Okay, So this quantity basically is equal to minus 3 by 2 to minus half. This is equal to, this is okay, this is okay, this is okay. For this quantity here we need 2x square, here we need 4x, here need 1, so we need to subtract this quantity. Okay, so this is 1 plus s the power 5 minus 2x square minus 4x minus 1, okay, dx. Okay, so this is equal to basically 1 plus s the power 6 upon 6 minus 2x power 3 upon 3 minus 4x power 2 upon 2 minus x, from minus 3 by 2 minus 1 by 2. If I calculate this quantity, we come to 5 by 6. Okay, this is our integration. So this is our I. Okay, so this is MIT 2023 integration B completion. So what is our question number 16? Okay, so okay, we come to question number 16 because I left this question. So question number 16 is I is equal to integration 3 sine 20x into cos 23x plus 20 sine 43x complete dx. Okay, so here is I used a formula like that, 2 sine a into cos b, this is equal to sine a plus b plus sine a minus b. Okay, so we need 2 here. Okay, so this is 3 by 2 and 2 sine 20x into cos 23. Okay, 23x plus 20 sine 43x. Okay, complete dx. Okay, this is 3 by 2. I use this formula. This is equal to sine 43x plus sine 23 minus 20. Okay, a 20 minus 23, this is minus 3x. Okay, plus 20 sine 43x dx. Okay, also we know that sine of minus x is equal to minus sine x. Okay, so here this is equal to minus sine 3x. Okay, this is 3 by 2 sine 43x minus 3 by 2 sine 3x plus 20 sine 43x complete dx. Okay, this is equal to, I separate this portion and this portion. This is equal to 43 by 2 sine 43x minus 3 by 2 sine 3x complete dx. Okay, so basically this quantity, if I taken 2, okay, so this is like 43 sine 43x minus 3 sine 3x dx. Okay, we know that integration of sine ax dx is equal to minus cos ax upon a. Okay, so this is 1 by 2 43 cos minus cos 43x upon 43 minus 3 minus cos 3x upon 3. Okay, cancel out this portion, so remaining portion is that this is cos 3x plus minus cos 43x. Okay, again I using a formula cos c minus cos d. Cos c minus cos d, this is equal to 2 sin c plus d upon 2 into sin d minus c upon 2. Okay, so this is equal to half cos 3x minus cos 43x. Okay, this is cos 3x minus cos 43x by 2. Okay, basically I is equal to 1 by 2 cos 3x minus cos 43x. Okay, here I use this formula cos c minus cos d is equal to 2 sin c plus d upon 2 into sin d minus c upon 2. Okay, this is 1 by 2 sin c plus d, 3 plus 43 is equal to 46 x by 2 into sin 43 minus 3 is equal to 40 x by 2. Okay, this is 1 by 2 into 2 sin 23x into sin 20x. Okay, cancel out this portion, so this is sin 23x into sin 20x. Okay, plus c. So our integral is equal to this quantity. Okay, so there are 20 question. I solve one by one each question. If you have any problem, then you comment on comment box. Okay, thank you.